The final component to learn about in this video is that. It's an LED. These come in all sorts of different colors and brightnesses, and they also come able to mount on a surface or through a hole. This kind is a through-hole LED, and it's 3 millimeters in diameter. So what's the point of an LED in a circuit? Well, it may seem obvious, but the point of an LED is to produce light. You can use these as indicators for when a device is on. You could use them as an indicator for when a button is being pressed. You can use them as the flash for a camera. You can use them as the lighting for a scanner. They're very, very versatile. So, an LED is a more complicated device to talk about than a simple switch or a resistor or even a battery, because they behave in some strange ways. For each color of LED, it will have particular properties. So this green one, this yellow one, and this red one all like to eat a certain amount of voltage, and that varies by color. It can also vary by the manufacturer. It can vary by the intended power output of the LED as well. A typical number for the amount of volts that an LED likes to eat is between 1.5 and 3. Some LEDs in the blue end of the spectrum will eat more than that, and some in the infrared may eat less than that. So, let's draw the circuit diagram for an LED. This one consists of a triangle and a straight line connected by wires, and these arrows indicate that light is coming out of it. LED stands for light emitting diode, and a diode is a device that only allows current to flow in one direction. If we put voltage across this LED backwards, plus and minus that way around, no current will flow. It will act like a switch, an open switch, and prevent current from flowing backwards. If instead of that, we put the voltage the correct way around, the LED will be very, very happy to let current flow. In fact, it'll be so happy to let current flow that it's likely to destroy itself with too much current. Current will flow from positive to negative in the convention for a circuit diagram. Because LEDs are very, very happy to transmit current in that direction, we have to limit how much power they can eat, how much current they can eat. And we do that by adding a resistor in series. That means next in line with an LED. A typical value for this, if we have 5 volts here and 0 volts here, we might have an LED which requires 3 volts, say, and we might have a resistor which has maybe 100 or 200 ohms. That's the rough value to get the LED lighting. For a specific application, you might choose different numbers than that. When you look at an LED, you'll see that it's got several indications for which way around it's meant to work. If you look from the top down on an LED, you'll see the shape of the bulb at the top. It's not shaped like a circle. Instead, it's shaped like a circle which has a piece cut out of it. When you're looking down on that, you know that the leg on this side is the negative leg. The leg on this side, the rounded side, is the positive leg. There's one more way to tell as well for a through-hole LED like this. You can see that the legs are actually different lengths. Whenever you see the legs are different lengths, the longer leg is always positive. The shorter leg is always negative. If you've built an LED circuit and the LED is not lighting, there's a few things to check. Number one, check the battery is able to provide more than the required voltage for the LED. Number two, check that your resistor isn't too big, or that you have a resistor at all. If you don't have a resistor, it might have broken the LED already. And the final one, the most common one, is turn it around and check that you haven't got it in the wrong way around in the circuit. So that concludes the first video on the most basic components of electrical circuits. Thanks for watching.